Well, welcome to our April 2023 Innovation Showcase. So I'll be handing over to Thurston to tell us all about Renolith. Thurston, take it away.
Thanks, Di. I appreciate the opportunity. Next slide, please. So my marketing lead tells me that I need to put an attention-grabbing slide up front, and hopefully this one does the trick. It shows a trial road built in northern Italy in about 2005. For the left-hand lane, you see the base was constructed with Renolith and cement, and in the right-hand lane, they used cement-only stabilisation, and hopefully you can spot the difference. Next slide. Some fast facts. Renolith is a nanopolymer admixture. It enables sustainable, low-cost, durable pavements to be built from any in-situ soil via conventional cold recycling methods, and roads are essentially immune to cracks, ruts, and potholes. The product's been used around the world in hundreds of projects with over 10,000 kilometres of roads built so far. First major project was the Sydney 2000 Olympics, where it was very successful in clay soils. Unfortunately, the genuine product was withdrawn from Australia over 20 years ago due to a messy commercial dispute between the patent holder and the previous distributor. My company reintroduced the product here just recently with the second generation formula. We're calling it Renolith 2.0, which achieves superior results at a lower dose. Now, we only have 10 minutes and a broad audience, so we'll just skim the surface. I'll focus on the sustainability aspects and the opportunity for Victoria's big build. So sustainability means different things to different people. We'll just go with a simple triple bottom line model. Renolith's applied via conventional cold recycling methods using cementitious binders, which enables rapid low-cost construction. However, it improves the results, enabling a broader range of applications. And since it produces a much better performing composite, that means less material and less cement. It works with any in-situ soil or recycled material, which eliminates the need for virgin quarried aggregates, and ultimately that means a much better outcome for the environment. Next slide. So nanopolymer admixture, not a common term. For our purposes, it just means a polymer-based admixture for cementitious binders, incorporating nanoscale materials. In this case, we have a latex polymer dispersion with nanoscale cellulose and silicon dioxide. The individual effects of these ingredients are well established in the technical literature. Latex has been used as an admixture since the 1930s, whilst nanomaterials have been the subject of a lot of research over the last decade or two. The unique genius of Renolith is that it combines these ingredients into an easy to use and extremely effective product, which is safe for handling and for the environment. Next slide. So what happens when we combine Renolith with binder, aggregate, and water? Basically, in the cement hydration reaction, nanomaterials provide the structure for the formation of additional hydration products, which fill the voids and improve the binding process. Next slide. Under the microscope, the images on the left-hand side show the cured material with cement only. And on the right, we can see the impact that Renolith has on the microstructure. So cement hydration products are more numerous and well formed. Gaps between soil grains are filled, reducing permeability, and the mechanical properties such as compressive strength, tensile strength, and modulus are improved. Next slide. Some applications. Here we have some European redesign examples for light and heavy pavements. On the left-hand side of each picture are the unbound granular designs. And on the right-hand side, the pavement's been redesigned as bound layers using Renolith, which enables a thinner pavement using less asphalt. Next. Now for a couple of case studies. First off, here we have an excerpt from a letter from the Sydney Olympic Coordination Authority. And if you're a speed reader, you'll see that cement stabilisation with Renolith was the main construction method for pavements at the Games. and it was very successful in terms of cost, construction time, and durability. Next slide. The Brenner Autobahn is a major European truck route that connects Austria to Italy. In 2006, a 5-kilometre stretch of the Brenner suffered shoulder longitudinal cracking, asphalt shrinkage and fatigue. Reconstruction of the southbound and northbound pavement was required. The existing base was made from inert material, coarse aggregate and no cement stabilisation. The area is subject to enormous fluctuations in temperature and powerful lateral water afflux at certain times of the year. The pavement was reconstructed over a 4-week period. The existing bitumen courses were removed, the existing base layer was strengthened with a mix of coarse gravel, 25 kilos of cement per square metre and Renolith admixture to a depth of 30 centimetres. A new asphalt wearing surface was applied. The Renolith admixture was beneficial in several ways. The pavement was trafficable after 12 hours and asphalt could be laid after 24 hours. It was possible to keep working down to -8 degrees Celsius. Compared to the alternative unbound granular design option, materials cost was approximately 50% lower and construction was 3 times faster. Thousands of tonnes of aggregates were not required, saving the associated emissions from quarrying and transport. A stiff, high-bearing capacity pavement was achieved, with EV2 field tests exceeding 1000 MPa, and a durable, frost-resistant pavement was created. Today, some 17 years, 30 million trucks and 150 million cars later, the pavement remains in service. No problems have been reported and no repairs have been necessary. So, moving on to Victoria, this chart shows a crude estimate of the materials and transport emissions per lane kilometre for a typical pavement, using a few different design options. The first design option is an unbound granular pavement, which requires a lot of aggregate to be mined, crushed, processed, transported and laid. And the transport component in the orange there, it's largely a function of the proximity of the quarry, which could be anywhere depending on where the project is. The second column shows the emissions estimate for the Brenner Autobahn case study we just saw, which used 25 kilos of cement per square metre. And the third column shows the Brenner example again, but substitutes a lower carbon binder, such as a blend with fly ash or slag. As we can see, there's potential to achieve some serious reductions in CO2 emissions. Next slide. So where might Renolith fit into Victoria's big build? For simplicity, we'll focus on a high impact strategy and limit ourselves to what's permitted under current specifications and standards. According to the waste hierarchy, the priority in order is to avoid, reduce, reuse, then recycle. So first of all, we avoid the use of virgin aggregates in base and sub-base layers. Secondly, we reduce greenhouse gas emissions by creating thinner pavements using slow or medium setting binders with recycled pozzolans such as fly ash and slag. Third, we reuse in-situ soils where possible. Now, as far as Renolith is concerned, any soil can be used, but fine, poorly graded soils such as silts and clays and reactive soils wouldn't satisfy the grading and plasticity requirements of Department of Transport and Planning Section 307. So in that case, we need something to supplement that, and that takes us to step 4, which is recycling waste streams into the pavement. And the easiest option is recycled concrete aggregate, either replacing or blended with the in-situ soil. Next slide. Moving on to a more immediate concern, the recent floods have made us acutely aware of the need for more resilient infrastructure. However, achieving this in an affordable way presents some technical challenges. For example, granular layers can disintegrate quickly in adverse conditions, whereas cemented materials tend to crack, providing vectors for moisture ingress and eventually potholes. Next slide. The good news is that a shovel-ready solution is already available with Renolith. the ability to create an impermeable, crack-free, full-depth monolithic composite using standard cold recycling methods makes it straightforward and cost-effective to construct a flood-resilient road network. And this has been proven in some very challenging environments, including monsoonal Southeast Asia and the swamps of Siberia. Next slide. So that's all I have today. I'll circle back to this triple bottom line graphic, and I'm happy to take any questions. Thank you. You're muted, Joy.
Thank you, Thurston. That was a rookie mistake. I'll now defer to our panel for questioning. Apologies. Yeah, thank you for redoing that. I appreciate you taking the time to re-present. I just wanted to be sure that you know, we give everyone equal time in the spotlight. So yeah, that was a great presentation. And let's if I can ask, it sounds to me like, so from a commercial perspective, are you ready to take orders, or is it still pending further research through RMIT?
No, we're ready now.
Yeah. Okay.
So it just depends what proof people want. I mean, we've got we've got a design guide, we've got all the documentation we need. So yes, we can take orders right now. The only real constraint is the lead time, because we need to ship from Europe, so that can take time. Yeah. But, yeah, absolutely. If there's a project that understands what this is, and it does take time to get your head around it, I think we could move very quickly.
I think outside of the big build, do regional councils, I mean, because I'm looking at, do they have any unique circumstances that mean that they might, this might be more, so I'm not sure. I mean, I'm not a road engineer, but so we do work pretty closely with Sustainability Victoria, who try to roll things out with local government. So so outside of the big build, these mega projects, do you see that as being a potential customer base, or is the big build where you see?
Look, absolutely. I think councils have got a real problem on their hands, and that they have a lot of really large road networks they need to maintain, and limited budget to do that. And then when you get something like the floods come through and destroys the network, it's it's a real challenge for them. So this is very well suited to their problem. And we've actually started an email campaign to councils, and we're getting a lot of traction with that. I think where big build could be useful is to give a bit of credibility to why we're doing this, tying in the sustainability angle, and give some confidence that there's some smart people in the engineering domain who are looking at this and
I think, and I know that's when we talk about big build being a catalyst, we understand that we can often be the flagship demonstration project for many of these things. So I'm wondering, I'm just thinking out loud, whether even major roads, Kui road upgrades, I know that is probably one of our more unique ones in terms of the twisty turns through the Dandenongs and out that way. That this is something
Kui road's a shocker. I mean, we drive that way sometimes, and it's always getting potholes because it's soft soil, I think. It'd be great for that, but I think that's already well underway, isn't it? They're doing
it.
That.
Look, it is, but I mean, for me, just even some of the projects, the Kui project, I mean, do have a bit of an appetite for innovation. So they're always the first to sort of stick their hands up and say, "Can we try this? Can we try that?" Okay. So I might circle around them and just see whether there's any opportunities there. No matter how small, I think it's there's that. My only other thought is, I mean, you're probably looking at permanent applications. A lot of the other major projects are setting up temporary haul roads at the moment for all their operations. So if you're looking at Northeast Link and Suburban Rail Loop, they're sort of in startup phase. So they're going to be doing a lot of clearing, a lot of temporary haul roads and things like that. But I think if it's a cheaper alternative than building a road, then they'll probably look at stabilizing instead of pouring asphalt that needs to be ripped up again in 3 or 5 years.
Well, yeah, I mean, not quite sure exactly on the context, but it does work quite well for those sort of roads. In the Sydney Olympics example, that's exactly what they did. They started using it for the haul roads, and realised it worked so well that they used it for everything. So look, I think it'd be great to get a local trial road up. I mean, I've got a small shipment coming. It'll arrive, I think, early June.
Yep.
It's probably enough for a trial road,
Yep.
more or less a section of trial road. So I think that'd be great if we could find a forward-leaning council or project under project that you know, wants to get the name out and doing something cool.
Yeah. Well, that's exactly the sort of thing that we do, and you know, we try to land outcomes for all our presenters. So that's something that we'll take away and work on from our end. So
great, thank you. Yeah, look. So yeah, as I say, 3rd of June the shipment arrives, so we're getting about just 800 kilos. So roughly 1 kilo per square meter is your usage, depending on the soil and you know, the binder you're using.
Yeah.
So that's enough for a trial road, I think.
Yeah.
Have like potential environmental impacts on, you know, the future surrounding environment. You know, can it release any sort of toxins? Is that sort of thing? Have you got data on that?
So the product itself isn't recycled. So it's an admixture for cement or cementitious binders. So, but in terms of the amount you use in a pavement, it's, you know, about 0.1% of the overall pavement mass. So the recycling opportunity comes from the aggregate that you'd use. You use in-situ soil rather than mining 200 million tonnes a year that we do of aggregates to put into construction. Now, so but the product itself, it's just essentially it's latex, so, you know, rubber, cellulose, and silicon dioxide sand. It's just very simple stuff, but because of the nano scale materials, it behaves in a very interesting way. So what it allows you to do is, because it binds the binder, you still need the binder, but it assists that binding process. So basically, whatever happens to be in that soil or whatever you want to use as your pavement layers, it binds it up very well, so that if you have a contaminated soil, for example, the chance of anything leaching out is much lower, because you get in sandy soils, at least, you get 100 times lower permeability. So there's a lot of applications there that could be explored. For the moment, we're really just looking at, you know, sort of simple, well, when I say simple, standard pavement applications, which will essentially be, you know, last for decades. So it's more like a concrete type result. So once it's bound up, it's not going to leach anywhere.
Thanks, Dustin. And one of your slides as well, I think it was that video you showed, the project in Germany, I think it was. They referred to the construction time, how soon after they could go and build the pavement and proceed with construction. Was that like a reduction from what it would have been if Renolith wasn't used? And I guess, coming from the rail industry, I guess something I'm interested in is, could this product potentially be used in other applications, like perhaps to stabilize a rail subgrade? Does it improve like the strength, and can it increase the speed at which you can start construction afterwards?
So speed of construction, definitely yes. It's a lot faster. I mean, this is just an inherent feature of using a cold recycling construction method, is that it's quite a quick process. The Renolith admixture shortens your cure time, so you're able to actually use that pavement sooner. In principle, yes, it could be used in rail, although I haven't done much research on that, so I'd have to be a bit cautious about saying what it could do there. But yes, I think there are good applications if there's interest in the rail industry.
Thank you very much, Dustin.
No other questions from the panel. Thurston, any final call outs or actions for the audience or panelists here?
Look, I think what I'll do is I'll put a document in the chat which has got some links to other resources, because it's a very complicated space, and it takes time to digest it all. And I did go very quickly. So anyone who's interested can have a look at that and follow their links, and be glad to hear what anyone makes of it.
Wonderful, thank you. And there's also 4 questions that are already in 5 in the chat group. that you can feel free to jump in there and answer those, Thurston. So
Oh,
yeah,
thanks,
anyway,
Tom.
thank you. Now, thank you for that. So I will now invite Brad from Transmutation to come and tell us all about transforming base metal into gold.
Very exciting. Thanks, Dory. I normally start by explaining the company name because I get a lot of comments about transmutation and people calling it transportation and all sorts of different variations. So transmutation's a term, an older word obviously, but it used to be used for transferring base metal into gold. It's our company name that quite suits our business at the moment, which is a small business. We basically take waste plastic and transport it and transform it into something better than landfill. Next slide, please. So if people have heard of transmutation at the moment, you're probably aware that we do products, homewares out of bread tags. So I know it's a bit of an odd way to come into a construction forum, but this is the business we are currently in. We've taken over 10 tonnes of bread tags that have been collected from all over Australia and saved them from landfill and put them into these homewares. The thing about the homewares are they are food safe, they're dishwasher safe, microwave safe, and we also have a collaboration with Country Road. So these products in a white form, white bread tag only, are going into Country Road as well. So it's been quite successful from a circular economy point of view to get an end market and a profitable small business out of it. So we're based in Robe in South Australia, halfway between Melbourne and Adelaide. And initially the business was set up to show that you could recycle just about any sort of plastic at this sort of scale. Next slide, please. So after being quite successful at that, I've taken on looking at other plastics that's coming through and scaling the business, if you like. So the styrofoam products here called the Styro Bowl, I've been able to take the styrofoam product and upcycle it, if you like, to a food grade bowl. Whereas currently uses of this type of plastic are going to coat hangers and picture frames and sort of recycle or downcycling. So been able to take that and make it into a product that can go into the homewares range again. And the thing about this product is it was scalable, so I can use traditional injection molding techniques and do this at scale. And these are currently being distributed through our online shop, but also going into Amazon and those sorts of stores. The thing about the last two products is we also sent them over for testing in Hong Kong, so they all have the certification for US, European food safe levels, as well as Australian as well. So we do go to that step to make sure that all of our products are quality tested. Next slide. So during the course of our business and taking single-use products, plastics if you like, and making them into something valuable for the marketplace, Dulux have come into our store, believe it or not, the operations manager for Dulux, and presented us with a problem, which was powder coating waste. So it's estimated that there's about 800,000 tonnes of powder coating waste, industrial waste around the world. So this is the waste that's produced during the manufacturing process, not the waste that's overspray, if you like, when you're using the product. So it's different. The industrial waste at the moment of powder coating is basically considered a nanoplastic, and it's being landfilled pretty much by all the organisations around the world that manufacture this. So Dulux in Melbourne have a problem. They presented me with their waste material, and I've been able to manufacture it or mould it into a plastic polymer, which is a mix of other polymers that I've come up with. It's a patent pending process. I'm on the last stage of that now. So that was filed in April, 23rd of April last year. And that's about to become, as a PCT international patent. So the process takes the waste powder coating. It makes it into this is just an example product, which is our bar chair, but it makes it into a moldable plastic in a pelletized form. It'll have its full certifications through GECA, which is I'm in the process of doing that now. and I'm also providing provenance for the plastic. So I'm using blockchain technology and some products to show where all of the plastics for this come from. So the end result will be 100% recycled plastic, moldable into any sort of plastic shape you want, especially in the sort of construction area. And the first product that we've done out of that is the 50-65mm bar chair, just as a proof point. Next slide. So just the process we've done here is because the polymer that I'm creating out of the powder coating is slightly different than what you'd find in the marketplace. We've got extensive sort of testing done to make sure that the strength parameters of the plastic would hold up. And we've redesigned this shape. So the bar chair traditionally will be quite thin. It'll try to use minimum amount of plastic because it's a cost, for that product. We've gone the other way with our design and made sure that it's thick enough to do exactly what we want it to do and meet the Australian standard before we make the mold. And we can do that pretty much with any product. We can make sure that the design of what the part that you're doing, and it might be an existing part that you do millions of, we can redesign it to make sure that the new material fits into that mold, or it might need some tweaking. Either way, the plastic we provide will be able to do the function to the Australian standard. Next slide. So the bar chair that we've come up with, it's me making it in the shed. We have done proof points at the moment. I've supplied it to a project in Melbourne, 2,000 bar chairs. So they're in a slab existing in Melbourne, no issues. And in fact, they're 200 kilogram rated. So they also have the added benefit of being quite sturdy. And the project that it went to had the self-leveling, or the machinery on top, which sometimes crushes bar chairs. So because they're quite a sturdy bar chair, it's not only the 100% recycled, the provenance provided with the plastic, the certifications, but also the fact that they're tough and they're strong. So they were well accepted by the steel fixers, and currently that was our first proof point. So this is the testing report, which basically just gives the Australian standard verifications that it meets the AS NZ 2425. Yep, next slide. Thank you. So basically, the bar chair is ready now. It can produce enough for projects, so I can do that in the thousands. We are in the middle of a scale. Our business is obviously small business, but with this patent pending and this product that I'm able to make, we're now scaling up to production. So by the end of the year, we'll be able to produce tons of pellets of this product, and also the bar chair product as well. We can also make, obviously, other sizes of bar chairs, any sort of other product that's out there in the concrete accessory sort of space. There's lots of plastic that's used in slabs. So that's the advantage of this product is we're really looking at firstly having the bar chair as the initial product, but we can pretty much mold any sort of product out of this plastic going forward. The other advantage it has from a environmental point of view is we can recycle this plastic after the molding. So those bar chairs can actually be recycled and reformed again. And the difference that we're doing here with the powder coating is the powder coating presently is considered unrecyclable waste material. So that's the patent process that's in the middle. So I've come up with some indicative pricing there. We sold the first 2,000 to the project for 50 cents a bar chair, which is quite competitive. And the pellets, we're looking at selling $2.50 a kilo, which again is competitive in the market for what you're getting. So at the moment, you'll get that the bar chair meets Australian standard, the provenance and the GECA certification is underway at the moment, basically. So that'll be finalised by the end of this year. So that's in a nutshell. Any questions?
Thank you. I now invite the panel to come back up. Irina, you switch your camera on first.
Yes, that's fine. Thanks, Brad. Look, all I can say is excellent initiative, and very good to see that any waste can be kind of utilized for something positive. So my only question, and I think you answered one of them, which is really, is it recyclable? Again, which it is, which is great. Do you see any how can I say barrier that to kind of continue to use this? And is that maybe related to the kind of demand that you're receiving? And do you have any problems with supply capacity, I guess?
Yeah, so basically all of those things at the moment, the production side of it is probably the easier of the problems. So that's scaling up my current facilities here at Road, and I'm also able to take this licensee type thing and do it in normal factories, if you like. So I can relocate and upscale in any of the capital cities if we need to. At the moment, by the end of this year, I will have capacity for all of the plastic waste that's coming out of the Dulux factory. So we're talking 500 tonnes per annum of production of this polymer, so it's quite a bit. So I see the second part of the question is the problem, which is the demand for it. I'm going to be able to produce a lot of plastic pellet which meets all of these specifications. It's then getting that into the marketplace and saying, okay, who can use this pellet? The advantage that we have is, firstly, I can manufacture all the way through at a smaller scale to the bar chairs or any other thing. I can also put that out, outsource that, if you like, to other normal injection molding factories and say, here's the pellet, here's the mold, please produce, thousands of these. So we can do that. But the other thing is people can introduce this into their current practices. So if they've already got thousands of, plastic widgets being molded by their supplier or whatever, then they can replace the virgin plastic with these pellets and get the certification and also the provenance and 100% recycled ECG credentials that come with this plastic, and their end product can then be made from this source pellet, if you like.
One more question. If you compare producing a bar chair with a recycled plastic versus using this type of material, would the production methodology vary, and would you then need additional energy or whatever it is to produce these bar chairs? And how does the carbon footprint compare? If you've done the comparison, of course.
I haven't done that comparison. That'll come when we're sort of in the middle of that at the moment, the GEECA accreditation. So we'll definitely have those that information. We're pelletizing it so that it can fit into the traditional injection molding industry. So basically we can present a standard pellet to an injection molder and they can mold it in, and we give the specifications for temperature and pressure and those things for the machinery to operate at. The other thing that we provide is we'll look at whatever's being provided, whatever's being molded, we'll look at that current design and make sure that our plastic meets the specification for what's being molded before we put it into the mold, because the mold's the most expensive part, obviously, of that process once you get that created. So if it can go into a current shape, no problems, but we'll test that on the computer programming before you start producing a whole heap.
Okay, thank you.
Thanks, Irina. Kerry.
Right, thank you for that. I think this is a great application of plastic. I just had one question. Is this product fully compliant with Victorian Section 610 for structural concrete? Because I understand they have some extra requirements above the AS 2425 bar space requirements. Are you able to provide any comments on that?
Yeah, look, I'm going to say it will be, but until I do the testing for that, and why I'm confident on that is because the properties I've got for this plastic are very close to your polyprop, which is your sort of preferred plastic in that space at the moment for the construction, the addition to concrete. So I'm going to say it won't have any problems, but at the moment it's at Flinders Uni, being chemically analysed so that I can get all the specifications I need to confirm that.
All right, fantastic, bro. Thanks for that. Keep us in the loop.
Thanks, Kerry. There you go. Victorian Spec 610. The one that you wrote, Andrew, or?
No, not me. No questions, Brad, other than just a comment. Look, well done on developing the smarts behind the technology. It sounds like the bar chair is just the first product in a whole line of new products that will be made available. So well done on that, and thanks for your presentation.
Thank you, guys. Yeah, probably with that, we can produce products out of this and sell that, but we're quite interested in partnering with people who are already producing products in that space, and we provide the material, because that obviously gets this into the market a lot quicker and gets the volume of plastic that I'm going to be able to create into that space as well. So.
Fantastic. So there's no other questions. Brad, any last call out to the audience?
No, bar chairs are us, but otherwise plastic's coming. So
Wonderful. Thank you for that. I think there's a few questions that have popped up for you, Brad, in the chat as well. So feel free to hop on in and have a chat to the audience. But thank you for that great presentation.
No worries. Thanks, you.
Now, I now invite Trent, I think, from the team at Saferoad.
Good morning.
Morning, Trent. Tell us about the rubber T-lock temporary barrier.
Yes, good morning. Thanks, Doy, and the rest of the team for inviting us. We're very, very pleased to be here today to talk about the rubber T-lock temporary barrier. It's absolutely the first in Australia and first in the world, as far as we can validate, that has a recycled content. And obviously, in this instance, it's rubber car tyres that obviously get shredded and granulized and repurposed in the format of a temporary crash barrier. Next slide, please. Here's a photo of the product. Finish of the product is as neat and clean, just as per the original MASH T-lock barrier that obviously consists of no rubber. And the product here consists of 4% of by volume of granulized rubber. So we're very excited about this. This is nearly a development that's been 5 years in its making. COVID certainly did hold things back while we were trying to develop the only 100-kilometre crash test facility here in Melbourne, or just outside of Melbourne in Warragul, and getting vehicles and getting set up. Next slide, please. So the company is a business that's all about innovation. You can see our motto there. We've been pioneers in the public and road safety industry for over 30 years. We offer industry expertise and the best design products available worldwide. We're very, very proud. Next slide. We're very proud of our, I guess, our history and our heritage. The business was I suppose, brought to life by the single innovation of repurposing car tyre tread back 30 to 31 years ago into a recyclable and a reboundable and fully flexible guidepost product. So a road edge marker post, and that's something our founder and CEO Darren Hodgkin started back in around 1992. So this is a space that I suppose we were probably doing some very innovative and interesting recycling back 30 years ago, when it perhaps wasn't as popular as it is today. So again, very passionate about that, and very excited about obviously what we're here to talk about today. I'm going to introduce Casey McMaster, who's our engineering manager. We will co-present today. I'll let Casey talk a little bit about the project, and we'll continue moving through the presentation today.
Next slide, please. Yeah, hi everyone. I was approached by Melbourne University almost 5 years ago to kick this project off, and the other partners were Tyres Stewardship Australia, adding expertise in the recycling industry and funding. APV Test Centre, we've been working with APV for a number of years on crash testing other road safety products that we develop. And Melbourne University was the the star of the show, I suppose, in doing the research and development on the technical requirements of the concrete, making sure the strength was right, working out what was the optimum quantity of rubber in the concrete mix, and what size rubber, particles, all that sort of stuff. So it was a great collaboration between these companies. And we'll just go to the next slide. There's a 2-minute video I'd like to show you.
This is another Australian homegrown idea that TSA has supported, taking it from lab straight through to product design. To date, TSA has committed over $8 million across 56 projects. This one, the road safety barrier, is just another example of how we're committed to using tyre-derived material in new value-added products.
Concrete is okay, but actually utilizing the waste tyre, we can improve the impact resistance. We can make the barriers which can last longer. And the test today showed that I think the safety of people would be further improved. And this really haven't been done before at this scale. We actually have done a lot of simulation, and the results show it actually provides a lot of benefit. But today we actually have seen how it works in real life. And it's a really successful demonstration.
From there, state road authorities, major road construction, civil contractors then have the first green option barrier in the country.
But this work will go undone if Australia's regulators don't step up and support the University of Melbourne and Saferoads and include this in the regulations. I'm personally passionate about finding new projects for used tyres. I want to see Australia be at the forefront of consuming its own material. I want us to help globally all other organisations that are faced with the same problem. It's not unique to Australia, but Australia can really step up, take its circular economy principles, make it work.
Well, you can see by the clapping and excitement at the end of that crash test there, very brilliant results. So the barrier, which the T-lock barrier, Saferoads have been selling for over 20 years, licensed from an American company with standard concrete, and had brilliant success with that product. With the inclusion of the rubber, it's reduced the acceleration forces on the occupants in the vehicle, and dramatically reduced the debris that comes off the concrete barriers with a typical MASH TL3 impact. And we managed to successfully crash test the product to the Australian standard 3845.1 road safety barrier systems and devices. And the crash test was done in September last year. And since then, we've achieved the ASBAP, Austroads Safety Barrier Assessment Panel approval of the product to 100 kilometres an hour. And from that, we've received approval from Transport for New South Wales, and it's currently being reviewed by the other states around Australia. Next slide, please.
So back to some of the environmental outcomes. You can see that over 58 million passenger car tyres reach their end of life in Australia each year. In partnership with obviously UOM and TSA, leading the way in the rubber T-lock in terms of sustainability and the temporary barrier market. It's an unrivaled recycled component barrier available on the market today globally. We have checked and validated that. The barrier is an opportunity for government road authorities and obviously contractors or any interested party in owning the asset for a for a rental type business to lead the move to the environmental responsible purchasing. As noted before, the barriers contain 4% recycled rubber content by volume. Tyre Cycle, which is a company that we've been working with, offer various grades. We obviously, through the research and all the evidence-based science and research from Melbourne Uni, 8 to 15 mil granules and 4% gave us the absolute sweet spot and gave us the absolute optimum in performance and longevity. This is evenly mixed through and batched through at the plant before we pour molds and mold the product. So it's an exciting, I suppose we're at an exciting point in the journey where very shortly these additional state-based approvals will be awarded and will be sent through to us. We are knocking on those doors pretty eagerly right now, and we are fairly close to being able to commercialise these. Next slide, thanks, Doy. So a couple of the really important things for us to get out there into the marketplace today. So if there's a big takeaway today, we've got a product that holds ASBAP approval, but the important message here from an environmental point of view and a sustainability point of view is that for every 1 kilometre of rubber T-lock barriers produced, we are going to take 12 tonnes of recycled tyre out of landfill and put it back into a product that is going to offer a very significantly improved lifespan based again on that science and that evidence from Melbourne Uni over the 5 years in the journey and their involvement in this project. The next slide just gives you a different visual of that. 2,000 passenger car tyres. Again, Doy has been privy to come to our premise and come to our facility. And I think when you hold a bag or a sample bag of 240 grams and you appreciate that 50,000 of those sample bags, and I'm talking about a sandwich-sized bag, I know people won't be able to see it here right now, but a sandwich-sized bag like that I'm holding, 50,000 of those will go into every 1 kilometre of barriers. So it's an important message and an important takeaway today. Next slide, and Casey can talk to you and just show you a small bit of the evidence-based research.
Yeah, so Melbourne University did extensive research on the rubber and how it behaves in the concrete. On the left-hand side there, you'll see they did some blast testing, 2 different types on concrete with rubber in it, and the damage is non-significant. On the right-hand side of the slide, you'll notice that the reinforcement bar in this little concrete blocks was exposed, and there's severe damage to the concrete product itself. So basically, Melbourne University did compressive strength testing, flexural beam, all that sort of thing, and finding out the optimum amount of rubber to put in our T-lock concrete barrier. Next slide, please.
So we want to appeal to the market and say why look at rubber T-lock? Well, there's some serious benefits here. There's an increased lifespan. Again, it's not based on anything but in terms of a gut feel. It's based on evidence. It's based on the science. And again, if you look back at that crash test video, and people can obviously access that, anyone dialed in today can jump online and have a look. If you look on the work zone side, the debris field is seriously reduced from typical concrete barrier crash tests. So there's a genuine improvement to the road safety outcomes and for workforce who are working on the work zone side of that barrier. It's a significant improvement. And again, all the evidence bases, all the evidence testing shows that there is going to be an increased barrier lifespan, potentially 50, potentially 60%, potentially 100%. We've also got the sustainability benefits in the fact that, again, for every 1 kilometre of barriers that we produce, whether it's in our 3.6 metre format or our 5 metre format, effectively 2,000 car tyres. And again, I think if everyone goes out there and drives home later today and thinks about how many cars are on the road and how many tyres we produce and just how much rubber 2,000 car tyres is stacked up in a shed or a warehouse, that's just 1 kilometre barrier. And we're talking about a market here in Australia that probably produces well in excess of 150 or 200 kilometres of barrier every year, Australia-wide. Next slide, please. Couple of additional comments to make and things to drive home. You can see there on the right-hand side, we've got a fairly detailed process and quite an enormous amount
I think we've
providers here in tyre cycle, and of course we have a very uniformed and very consistent product that we can quite easily replicate barrier by barrier. We've got the only recycled rubber crash-rated barrier currently available on the, in the market here or anywhere. We have a product that is now approved by ASBAP, obviously the authority in the in this space in terms of the approval of both permanent and temporary barriers. And we've got significant sustainability benefits depending on the market and their support for this innovation. Next slide, please.
A couple of comments there. One from Lena Goodman, CEO of Tyre Stewardship Australia. This is yet another example of Australian ingenuity and innovation at its best. And we're very proud to have supported a new homegrown product go from the lab to the real world. And the next one's me, but I'll just talk about, I've been working with Saferoad. It'll be come up 20 years in about 5 weeks' time. I've developed road safety barriers from scratch, steel and concrete, hybrid barrier, the HV2. And it's we also developed designed and built currently the only crash test facility in Australia that's able to run MASH TL3, 100k an hour, 25-degree impact with a 2.27 ton pickup, which meets the Australian standard. And I'm absolutely ecstatic that we were able to work with Melbourne University and bring the sustainability of incorporating end-of-life tyres into a crash-tested barrier that performs more than what we expected. And we're contributing to the sustainability of the Australian economy. So next slide, please.
Final comments and questions, and hopefully for us, this is only the start of, I suppose, a rejuvenated effort and commitment to looking at further ways that we can incorporate recycled content into an array of our barrier and other products that we bring to market.
Brilliant. Thank you, Trent. And I invite our panelists for any questions. Might start with Andrew.
Thanks, Trent and Casey, and well done on seeing an idea through on I think you said a 5-year journey from an idea through the lab testing into practice. It's a credit to you that you persisted. Just in terms of the rubber itself, you spoke about shredded rubber product. Does the rubber source matter? You said car tyres, can be truck tyres, can be mining tyres. Does the tyre have an impact on performance?
Yeah, absolutely. The tyre cycle actually do use truck tyres as part of their recycling processes, and a substantial amount of truck tyres is incorporated into the rubber T-lock. So the range of tyres is endless. It's whatever's available is able to be used in this product.
Right. And you indicate that performance is superior to the conventional barrier. So how do you compare on price?
Okay, so we obviously have to purchase the tyre crumb. The batch mixture is slightly different. There is a small increase in labour cost too, because we probably do spend a little bit more time vibrating and agitating the moulds to get the right finish. Whilst that's all been proved out, and we've done it obviously for the barriers that we produce for the crash test, there is a small premium, but we feel somewhere in the vicinity of around a 15% premium for the Victorian market, with a product that's probably got well in excess of a 50% improvement in lifespan is fairly justifiable, and also noting some of the significant sustainability benefits depending on the project and depending on I suppose the extent of what they're trying to achieve from an environmental perspective or from circular economy objectives, and those points of view, I think. So
no, and I agree. I think using the rubber itself is a sustainability initiative, but if you get longer life, well, that also goes into the sustainable assessment as well. So
absolutely. And I think for anyone who's dialed in today that's seen, you know, concrete barriers, you know, they are built to withstand a 100-kilometre impact. But as far as incidental knocks and bumps when they're being loaded, unloaded, being deployed, being removed and shifted on site, they are quite prone to a bit of damage. You know, whether it's a crane, whether it's an operator, they're quite prone to getting chipped and cracked. And obviously, there's a point in time where there's a point here where we've got a product that is going to demonstrate significant better ability to withstand those sorts of beatings and those sorts of what I call it, more minor impacts than a full-scale 100-kilometre hit out on site.
And just a final question, can the concrete mix technology be used in other applications?
Look, we're early days here, but there's certainly been some internal conversations. We have another product, which is our HB2 barrier. It has again, a significant concrete infill. It's a steel shell filled with concrete. It's a TL4 product, also freestanding, so no pinning or anchoring as per the conventional steel barriers you see on the market. We have had some internal discussions at this point that product could see an increase in the rubber recycling content, yet to be validated and proven out. But because of the structural significance of the steel shell, the concrete structure and the structural integrity of that is not quite as critical to the performance. It's more about the fact that it's got the mass and the ballast there to be able to perform. So there are definitely other avenues for Saferoads to be exploring, and we I suppose we're only a little way down that track, but we firmly believe this will become another benefit here in Australia and indeed overseas, where there's a lot of interest in that particular product.
Thank you, Trent and Casey. Well done.
Welcome. Thanks.
Irina.
Thanks, Stoy. Once again, an excellent initiative, you know, and it's great to see that, you know, the tyres are actually used for more and more products, and hopefully this will become business as usual, I guess, down the track. I've got also a few questions, three in fact, so I'll go one at a time. The first one is, can this material be recycled again?
Okay, at this point in time, we have a small rental business and a small rental division. Many of the barriers, and probably close to 80–90% of those, would actually find their way from being deemed internally a non-crash rated or non-crash worthy barrier. So we're going to call almost, there's probably 2 points where we can classify end of life. So I think first one would be to say, when we've deemed that, you know, it's maybe got a crack around the lifting point or a crack around the, and I'm talking about conventional barriers here.
Without rubber.
Without rubber. So typically, you know, when there's enough deformation on that product to deem it unworthy, they're quite often then repurposed and reused in non-crash tested applications. So they might get used in plants, in all around different, you know, different infrastructure. They might get used in agriculture, they might get used in retaining walls, they might get used for a whole other range of purposes. So look, we're pretty confident at this point in time, the barrier will obviously outlive the conventional product, and they will still be able to be repurposed and reused as a non-crash tested device later in their life. When we get to the ultimate end of life, we're still working with various recyclers at this point in time to see what the avenue is longer term. We haven't got a successful story there yet to tell, but we're working closely with obviously TSA, Tyre Stewardship Australia, and we'll talk to obviously various recyclers to see what is the capacity for that product to be broken down further at the very end of its life, which again we expect would be well down the track from the conventional concrete barrier available in the market today.
Okay.
There's potential for the concrete barriers to be crushed up and put into, you know, lower sub-base roads. Currently, road authorities put recycled tyres into asphalt. You know, the end of life asphalt gets stabilised and that gets, you know, chewed back into the lower bases of the road. So I can see we'll need to work with road authorities through that process and get approval for that'd probably be a great sort of next life for the concrete barriers once they're not fit for purpose for crash testing, and for that proportion that can't go into other purposes as complete whole barriers.
I mean, I'm sure there'll be applications where it can be done as long as, you know, it's known that this is the material kind of composition of this particular recycled material. So you know,
Absolutely.
it's just a matter of my second question, yeah, it's great that you've maximized the amount of rubber in the product, which is 4%. But I'm interested more in the concrete kind of mix that you're combining with it. You know, have you tried maximizing the recycled materials in the concrete mix as well, on top of, I guess, using the rubber? And did you test such materials, you know, in kind of recycled?
There's additional fly ash in the mix, in the concrete mix. So it was the initial proposal for this project with Melbourne University was strategically to incorporate the rubber. There certainly is opportunities in the future for additional materials, because there's all sorts of different materials in concrete now. It's ridiculous. but we were really focusing on the rubber tyres for this particular project. But yeah, Melbourne University, they're definitely interested in continuing research and seeing what else they can apply that'll give us the same behaviour and performance.
And I'm just talking about that pure green, I guess, label,
Yeah.
you know, like to have the pure green, we have to reduce obviously what's in the concrete a lot as well. So that was my second. And the last question is, what prevents you to continue and apply this to a permanent barrier, T3 or T4?
Very glad you asked, actually.
Question. Yes, so our next project, we've already applied for funding for another joint venture with Melbourne University for that exact purpose, using the T-lock connectors and for precast elements in for use on permanent road barriers. So, and I've got a meeting with a company next week that we've been in conversation with for 6 months or so now to progress that project. So watch this space.
Great to hear. Thank you.
Yeah.
Thanks, Irina. Kerry, from any questions from the rail perspective?
Well done, Trent and Casty. It was very good, and loving the beard, Casty, rocking it. So very nice. From a rail perspective, I'm definitely interested in what other applications we can use, because we've got a lot of pier protection for bridges, deflection walls for rail collision loading. Did you? I know your company name Saferoad, so maybe not, but I'm just curious if you explored the potential of the application of this in other impact applications like around that.
So you're talking for temporary barriers to be
permanent
around?
Permanent in the permanent infrastructure. So you got your bridge pier protection, deflection walls.
Oh, I see. Yeah, permanent
permanent stuff with a 100-year design life.
Right. Look, that certainly wasn't on our radar for this initial project, but it's something that we can definitely look into. It's where after this successful project as a joint venture with Melbourne Uni, Tyre Stewardship Australia, we're definitely open to ideas of how we can extend the product range for this technology. So nothing yet, but we can certainly have a discussion together and see what you want to achieve, and we can help you get there.
Fantastic. Thanks for the insight into that, and keep up the good work as well.
Cheers. Thank you.
Thank you, Kerry. That brings us to the end of our presenters. So I just want to, I suppose, actually, before Trent and you duck off, just to be fair on yourselves, being that you presented last, we do have a number of questions that have popped up in the chat. So I'll probably read them out to you. So I think some of these have been answered, but just the first one is from an anonymous attendee. What is the source of the tyre rubbers? Is it local or imported?
Local.
Yeah, so because Tyre Cycle Australia process Australian rubber.
Australia, absolutely. Yep.
The next question from Jade here is, how do T-lock barriers compare to traditional concrete jersey barriers in terms of weight, handling, availability?
Okay, so from a weight perspective, because they've all got a very, very similar profile, which has been obviously proven over probably the last 5 decades, weight per lineal metre differs almost marginally, less than 2 or 3%. So from that point of view, almost the same. And I guess whilst we found the sweet spot with 4% by volume, we haven't seen a significant reduction in the weight of the barrier. So the weight of the barrier is still fairly critical to its overall performance. The shape of it obviously also determines that the weight's going to be quite the same. Sorry, the second part of that question was
weight, handling, availability.
Handling. So look, handling is going to be very, very similar. I would certainly suggest that from a handling perspective, those incidental knocks that concrete barriers consistently get when they're going in and out of a depot or on and off site, okay, this particular product is going to handle that significantly better. And I guess ultimately production, we are absolutely ready to go in Victoria and 2 of our partner sites where we would precast and manufacture these with a couple of our partners in New South Wales and Queensland are very, very close to being able to turn the tap on. So we've got molds, we've got them set up. It's just a matter of once those orders are placed, we can obviously gear ourselves up to move ahead with production. Victoria, I think, will be only a matter of time. There are obviously a number of very interested parties here and now, and I'd suggest within the next sort of 4 weeks we'll be commencing our first pour for our first really sizable order.
Thank you. There's a few other questions here which I think have been answered already around it uses both truck and passenger tyres.
Yeah.
We've spoken about end-of-life recyclability, and I'll ask this one. I think because obviously there's everyone's cogs are ticking around what else is next. But question is the idea transferable into ready-mixed concrete scenario for cast in situ or slip form barrier design? From one for Casey, perhaps.
Oh, look, I'd suggest yes. I can't see any reason, going on the journey with Melbourne University and following their research. From an engineering point of view, absolutely, I can see it. You might be able to go down to Bunnings and buy a bag of eco concrete mix for whatever purpose. So yeah, I think that certainly is possible.
Fantastic. And the last question here from Daniel is, has there been any interest in this product from road safety traffic management companies?
Road safety traffic management companies. I'm trying to think where they specifically sit in the market. I'll answer that question straight up. There is interest at significant construction projects. We've already got interest from different rail and level crossing removal projects. We have a couple of other projects that have got some real sensitivities around their environmental, the environmental aspects on their project, where they are looking to obviously incorporate this into their overall sort of circular economy objectives in I guess combating some of the environmental challenges that they have. So at this point in time, I would suggest there is a lot of interest across the sector, without specifically saying it's either from just a traffic management company or just contractors or just other people, whether it be other hire companies who might be interested in owning a fleet of these, particularly when we talk about a significantly improved lifespan and shelf life of the product. So I would say that the interest at this point is not specifically one subsector, but the whole market in its entirety. I'd say the interest and the expressions of interest we've had already is very far and wide.
Fantastic. Thank you. Thank you for your presentation. That brings us to all our questions. For the rest of you, if you've enjoyed today, please get in touch with the team here at Ecologic. So you can drop us a line at our email there. We've got a treasure trove of resources on both our Knowledge Hub on our website, from reference guides already listing all the standards and specs that permit for you to use recycled materials, right through to case studies and other material that you can get stuck into. I'll take this opportunity to announce that we will have an Ecologic conference and trade hall this September. I think if you're on our distribution list, you would have received a save the date. So if you want to get hands-on and learn more about recycled materials, I encourage both our presenters and our audience members to get involved and come exhibit or come along to that event. If you'd like to meet more businesses like some of the ones that presented here today, on Friday, May 28th, we'll be organising our next online networking exchange. People call this speed dating, but we'll be using Zoom's breakout functions to try and match any one of you there in the audience. So whether you're coming from one of our big build projects or local government, or you're a technical advisory and you just want to meet more businesses like some of the ones that you've presented here today, then register for that event when it comes out as well. And last but not least, it's 2023. The socials is where people find out information most quickly. So please follow us on LinkedIn if you haven't already done so. It's genuinely the fastest way to find out what's happening in the space. Thank you again for dialing into our April showcase, and I hope to see you again at our next one, which I think this rate will probably be sometime in June. And thanks again to our presenters and panelists. Thank you.